Welcome to my presentation. My name is Denise Tatih. Today I'm going to be talking to you about CalmChat. CalmChat is a mental health conversational agent I chose as my project for the KaggleX Cohort 4 Fellowship. I am a medical laboratory scientist, have been for 13 years, recently got a master's degree in business analytics, and I am an aspiring machine learning scientist. The presentation will proceed according to the table of contents. I'd like to start by thanking KaggleX for the opportunity to fellow with them. I'd like to thank my advisor for his help during this process. I'd like to thank my friend and family for emotional support. I chose mental health because it is a big problem in the US and worldwide. It is hard to find a person who has not been touched by mental health, either through a family member or a friend. 5% of adults and 13% of youth, according to Mental Health America, have reported experiencing serious thoughts of suicide. Many people, when they're in crisis, do not have access to therapy, either because they do not have insurance or their insurance do not cover mental health. 10% of adults and 8.5% of youth report that their private insurance do not cover mental health. I believe in scenarios like this, a chatbot, a mental health chatbot that's properly designed with the proper guide rails can be used to provide emotional support. This support can be affordable and easy to access. The goal of this project is to fine-tune open source Gemma models with therapy type datasets, then deploy the models to Kaggle and Hugging Face, and then finally build a user interface. Data was collected from 4 datasets on Hugging Face, and additional dataset was generated using ChatGPT. Topics were extracted from the 2 websites listed below. Data was cleaned by dropping duplicates, removing foreign text, removing extra punctuations and symbols, and trimming white spaces to get a total of 302,119 rows with 2 columns, question and response. 3 models were fine-tuned, 2 2B models and a 7B model. The 2B models were fine-tuned using a GPU accelerator. All 3 models were fine-tuned using Keras and a JAX backend. Distributed tuning was used for the 7B model with a TPU accelerator. Fine-tuning was done on Kaggle and Collab. Distributed tuning was done for the 7B model because that model was too big to load on one TPU device. The model was divided onto 8 TPU devices, thereby making fine-tuning possible on Collab. After distributing the model on 8 devices, LoRA was activated at a rank of 4. Fine-tuning LoRA at a rank of 4 meant freezing most of the 8 billion parameters in the 7B model and fine-tuning and training just 11 million parameters. After fine-tuning, I acquire a sparse categorical accuracy of 0.8722 and a loss of 7.9622. The fine-tuned models were then deployed onto Hugging Face and Kaggle as shown by the links on the screen. A user interface was built using this fine-tuned model on Hugging Face as shown on the screen. This user interface included all 3 models as shown here. Using a drop-down, you can select from the 3 models. Then there is a chat box area where you get your response, and there is a system prompt area where you guide the robot on how to respond, and there's a prompt area where you can type something like I am sad or I am happy, or you can type a question like what is anxiety. Then right below there were options for temperature and other parameters that you could use to adjust how the robot responds to questions. I believe that mental health is a big crisis, but chatbots could help alleviate this crisis by providing emotional support. This chatbot needs to be well designed and they need to be guide rails to make sure they're safe for the users. Thank you for watching my presentation.